The last section of Unit E is something that's near and dear to my heart. I teach chemistry as well as math, and dimensional analysis in chemistry and physics is so useful. The other thing that it's useful for is because we live um, close to the United States and they still have the imperial system, sometimes we get caught between imperial measure and metric measure. And dimensional analysis is really looking at the units, so the dimensions things are in. Oops, that's units. Unit analysis, if you will. We have equivalent statements. And so a lot of the time people know how to convert from miles to kilometers or pounds to kilograms or those kind of things somewhat intuitively. Dimensional analysis gives us a framework for converting units even if we don't know what we're talking about so much. So, you don't have to have it memorized. It's a problem-solving strategy in converting from one thing to another. So, inches to feet is an example, meters to millimeters. In chemistry, moles to atoms or grams, right? All of these are really, really useful. Conversion factors are like a bridge, if you will, to go from one unit to another. The last page of these notes has a number of conversion factors. There's very few that you need to have memorized. They really are facts, and it's about how we kind of manipulate these conversion factors that will do the math for us. So here we have an example, which I think is probably the best way to illustrate the how-tos in these. So we want to convert inches and feet. So we start by finding a unit factor, a conversion factor that links those two. You can take a look just up above, 12 inches in 1 foot, right? That is my conversion factor. That is something, and in the keys for this, I highlight all my conversion factors just because I tend to put a box around them and then it's a little bit confusing, right? So we've got our conversion factor. The next thing you're going to do is start with what you know. So what we know is 6 feet. The next thing we're going to do is arrange the unit factor so that the units cancel out. So I'm going to multiply this by the unit factor. And I'm going to arrange this unit factor so that the feet are on the bottom, because feet divided by feet would cancel out, and inches are on the top. I can see from my conversion factor I have 12 inches and 1 foot. So this has it all set up so that I can do the math, right? The key thing in this is analyzing the dimensions. If those cancel, my answer is going to be in inches. The key thing to remember is that if it's on the top, you multiply. Oops, multiply. If it's on the bottom, you divide. You can ignore ones, because multiplying by 1 or dividing by 1 doesn't do anything. If you want to, you can on your calculator, but in my calculator, what I'd punch in here is 6 times 12 equals 72 inches. So if you're 6 feet tall, you are 72 inches tall. And if you've done carpentry, this stuff you do in your sleep, right? You don't need to write it out with dimensional analysis. You probably just know that. What I'm trying to do is give us a skill with dimensional analysis that links into this ratio and rate unit, because it's such a valuable problem-solving skill, especially when you're outside of your comfort area. So this one, we're going to start out easy, is much like what we did before. I'm going to read it and figure out what I'm talking about here. So we want to know how many feet, right? And we've measured it out in inches. So I would need a conversion statement, a unit of truth, something that somebody tells me and I read off a piece of paper or whatever. There are 12 inches. Oops, sorry, that doesn't say 12. 1 inch. Oh my goodness. Let's try that better. My answer key has a mistake in it. I wrote it backwards. 12 inches in 1 foot, right? So I have my conversion statement. I have my unit factor. I'm going to write down what I know, 124 inches. I'm going to arrange this so that inches are down below because that would cancel them out, and feet are up top. So I've analyzed my dimensions, my dimensional analysis, and the numbers that go with these are right from my unit conversion. And so this allows me to see that inches cancel, and my answer is going to be in feet. On my calculator, it'd be 124 divided by 12, and that would give me 10.3 feet. So that's fine as an answer. If you are a carpenter, you know that that's actually 10 feet 4 inches, because that would matter. And so don't worry about that if that's not you. But honestly, this stuff is stuff you've probably done before. The next question is very real. So I don't know how many meters I am tall or kilograms I am in weight. I tend to talk about how many feet tall I am and how many pounds I weigh. So we want to convert inches to meters, right? So we need a unit factor for that, and we want to convert pounds to kilograms. So the first thing I'm going to do is find those two things. We're going to talk about height, and we're going to talk about weight. In all these, we're going to round to 1 decimal if needed. So the unit factor I found is 1 inch is 2.54 centimeters. And again, I'm dealing with the very last page of this unit, or you also have it in your formula sheets. The other unit factor that I'm going to deal with is between pounds and kilograms. So the one that I found is 1 kilogram equals 2.2 pounds. Sometimes you can find alternative unit factors. You might find one that's 1 pound is, however many parts of a kilogram. But I just always write out the ones I'm using. Usually it's just a matter of rounding error. If you pick a different unit factor than I did, say on a test or something, I give you the benefit of the doubt. Okay, so we've found our unit factors for these. We're going to start with what we know. In height, we have 68 inches. I'm going to arrange my unit factors so that inches are on the bottom and where I'm going, or centimeters, are on the top. So I'd have 1 down with the inches and 2.54 with the centimeters. That tells me I'm going to multiply these numbers. Rounding it to 1 decimal, I get 172.7 centimeters as his height. Same thing with his weight. I start with what I know. I know that he's 190 pounds. Do you know the LBS for pounds? I hope so. 1 kilogram is 2.2 pounds. I knew to put the pounds down below because that's the unit that I want to cancel, right? This tells me it's 190 divided by 2.2. So on my calculator and rounding to 1 decimal, I get 86.4 kilograms. So between the imperial and metric system, it's a very real thing to do dimensional analysis, also within the metric system. So the metric system is based on powers of 10. If we want to go meters to millimeters, I know that there are 1,000 millimeters. Whoops, that's 1,000 millimeters in 1 meter. And again, that is pulled from something I knew. It's not off the top of my head. I have my conversion factor. I'm going to start with what I know. And I'm going to use my conversion factor in a way that it does the work for me. Meters would go on the bottom because that's what you want to cancel, and 1,000 millimeters would go on the top. So I multiply 4.2 times 1,000, and you might have known how to do that intuitively, which is awesome if you know the answer. But dimensional analysis is a fantastic strategy if you're not certain of how to just get to the answer. Last one, if we want to go from meters to inches, you may be able to, like, say, punch that into the internet and find a conversion factor. Sometimes you need multiple. So if I'm using the last page of the notes or the chart from our formula pages, I would find 2 different ones that I could use. So this might be the first time you've seen it done like this. I know that if I have to go from meters to inches, I could go from meters to centimeters and then centimeters to inches. So I'm going to find 2 unit factors in this one. 1 meter is 100 centimeters, right? That's 1 unit factor. The other unit factor, and this is from the chart that I put in the notes, 1 inch is 2.54 centimeters. So always you found your unit factors, your conversion statements, right? You're going to start with what you know, 5.6 meters. We're going to go from meters to centimeters by putting 1 meter down below and 100 centimeters up top. My meters are gone. My answer is now in centimeters. Instead of calculating that, I'm going to tack on the next conversion factor. I would put 2.54 centimeters down below and 1 inch on the top. If you take a look, the centimeters have canceled and now your answer is going to be in inches. So this is where I said on the first page of this section, if it's on the top, you multiply by it. If it's on the bottom, you divide by it. So on my calculator, that's 5.6 times 100 divided by 5.42, or sorry, 2.54. Punch that in correctly. If I do that in this whole page, I'm rounding to 1 decimal. If I need to, that's 220.5 inches. If you're multiplying and dividing by 1, that's absolutely fine, but it's not going to change your answer, and so I leave that off. You can always go back and do this checking to make sure you've got everything correct. This zigzagging pattern and what's left over, what doesn't cancel out, should be the units that are in your answers. All right, we've got a few more to do on these ones, and most of these ones are multi-step ones. So usually one at a time isn't too bad, but these multiple step ones are sometimes a little more problematic. You also, I noticed on your conversion factors, don't have anything about time. So there are some facts about time that we're going to need to go from days to seconds. I'm sure you could look up how many seconds are in a day, but we can get there with things we just know. We know that one day has 24 hours in it, right? That's a truth. We know that 1 hour has 60 minutes in it. And we know that 1 minute has 60 seconds in it. And so if we use all these conversion factors, we can go from days all the way to seconds. I've got my conversion factors. I'm going to start with what I know. So for days, I'm going to arrange this first one, putting days down below and multiplying that by 24 hours. The next one, I put 1 hour down below to cancel the hours and 60 minutes on the top. I'm almost there. You may have intuitively known just to multiply by all these numbers, but I am trying to give us the skill of dimensional analysis. So now that I've got all this written out, I can do the math. You'd multiply everything, and my answer should be in seconds. So on my calculator, that worked out to 345,600 seconds. Don't ask me the usefulness of calculating that, but you can. All right, another one. These ones are common in physics. So we often talk about kilometers per hour if we talk about rates of travel. In physics, it's always in meters per second. This one, influenced by the state, we're going from miles per hour to feet per second. Not in the metric world, but that's okay. So we're going to have a few conversions here. We want to go from miles to feet and from hours to seconds. So there's 2 parts going on, which makes these even harder than the multi-step ones, right? So if I list the unit conversions I need, I'd start out with the miles and feet, and I can look on the back page. 1 mile, I wouldn't have known this, maybe you do if you grow up in the imperial system in the stateside, is 5,280 feet. With the time ones, if I want to go to hours to seconds, I've already done that up above, right? I know that I've got, I'll just highlight them up here, 1 hour being 60 seconds and 1 minute, or sorry, 1 hour being 60 minutes and 1 minute being 60 seconds. So these are the 3 unit factors I'm going to use converting in this question. The other part that's a little different with this is I'm going to write this as 65 miles per hour. By putting that rate, that second unit down below, I can see how it cancels with this unit analysis. I'm going to start with the miles. So I'd want miles to cancel, and I'd want it into feet, right? So 1 mile is this 5,280 feet. My miles are now good and my feet are where I'm at. The other thing I want to do is make this hour into seconds. And so to do that, the hours, this is a little different, are going to go on the top, right? That would cancel the hours. And what I want down below would be minutes, right? In 1 hour, there are 60 minutes. I need to use the last one here, going all the way, not to feet per minute, but feet per second. Minutes I'd put on the top to cancel out and put the seconds down below. So it'd be 60 seconds in 1 minute. And with this dimensional analysis, if I circle the units I have left over, I would have this in feet per second. So if it's on the top, I multiply by it. If it's on the bottom, I divide by it. This whole page, I'm saying just round to 1 decimal place, a rather arbitrary piece of instructions. I get 95.3 feet per second. We have one more that's kind of like this. So we have Jenny running 500 meters in 4 minutes. And we want to turn that into kilometers per hour. So I'm going to need some conversion factors, most of which I already have. There is 1,000 meters in 1 kilometer, right? And the other ones that I need are the time ones that I've used already here, going from minutes to hours, right? There's 60 minutes in 1 hour. So I'm going to start with what I know. And this time what I know is a little bit different. So 500 meters in 4 minutes. Using my dimensional analysis, I'm going to convert to kilometers on the top and hours down below. So I'm going to start with the kilometers and the meters, right? I'd have 1,000 meters down below and 1 kilometer on the top. That cancels my meters, and now I'm in kilometers. I'd also like to switch from minutes to hours. So minutes would be canceled if I put it on the top, and kilometers per hour if it was on the bottom. The unit factor that I guess I just have to know, because again, I said it, they're not listed on your chart. You can add them for sure. 60 minutes in 1 hour. And so now I'd have kilometers per hour if I do the math. If it's on the top, I multiply by it. If it's on the bottom, I divide by it, and I get a final answer, rounding to 1 decimal place, of 7.5 kilometers per hour. All right, the last one's kind of a tricky one. It's really just for fun. Somehow at your workplace, you have established a most ridiculous barter system, completely fictional. This makes no sense for real life. But Annette, what it's saying is that you have 50 strawberries and you have this system in place and you would like to trade for sugar, right? You'd like sugar to come out of this ridiculous barter system that you're going to put in at strawberries. So our unit factors are all listed out here, and we're going to start with 50 strawberries. Okay, so if I have strawberries, I can convert them to eggs. 14 strawberries would give me 2 eggs, right? Just looking at the unit, the math will follow. The strawberries are canceled. Now I have, in the currency of eggs. I can trade eggs for flour. Eggs would go down below and flour would go on the top. It's 6 eggs gives me 2.5 kg of flour. All right, so eggs are gone. Now I have, in flour. The flour would net me 2 liters for every 1.5 kilogram of flour. So what I'm writing is the 1.5 down below and the 2 liters on the top. That's milk. Oh, I'm running out of space. Okay, so the flour gone away. Now we have it in liters of milk. This one's a little tricky. This would actually be 0.8 liters, right? We'd want to write that down below, so 0.8 liters milk would finally give me 4 cups of sugar. So the milk is gone, and I should have this in terms of cups of sugar. So on the top I multiply by, on the bottom I divide. So it'd be 50 times 2 divided by 14 times 2.5 divided by 6 times 2. You get it, right? All of this would round to calculates to 19.8, or rounding to the nearest cup, that gives me 20 cups of sugar. And an overly complicated and time wasted on in your workday, I think. All right, so that's dimensional analysis and the end of Unit E.